Welcome to this video where we explore how CRETA helps manage and shorten the software update release cycle in a CI/CD pipeline. Let's start with a brief look at the evolution of battery electric vehicle software and parameter management. As electrification has advanced, the complexity of BEV software has grown exponentially. In the early stages, battery and powertrain control required the calibration of a few thousand parameters. Today, the number has risen to over 50,000 and includes areas such as battery management, thermal systems, and energy efficiency optimization. Managing this vast number of parameters is critical for ensuring vehicle performance, safety, and regulatory compliance. Modernizing software for the development of BEV with automated CI/CD pipelines presents significant challenges for traditional sequential methodologies. Many OEMs are challenged with complex and slow releases. The increasing complexity of software requires a seamless integration of development, calibration, and testing to ensure efficiency and reliability. Software development for BEV follows modern CI/CD and DevOps principles. Initially, software is developed for a single vehicle architecture and undergoes the complete DevOps cycle. However, the challenge extends beyond a single model. Large OEMs use the same software across multiple BEV platforms with different battery configurations, drivetrain setups, and energy management strategies. Traditional version control tools like Git and TFS struggle to manage the complexity of calibration data and software variants required for BEVs. Another key challenge is that software engineers and calibration engineers work in different domains. While software engineers focus on control logic and algorithms, calibration engineers fine-tune energy management, charging strategies, and thermal behavior, often using specialized tools not designed for CI/CD workflows. This is where AVL CRETA, the market leader in calibration dataset management, plays a crucial role. To streamline BEV software development, it is essential to decouple software development from calibration parameter management. Instead of maintaining multiple software versions for each vehicle variant, a single software baseline can be developed and adapted through calibration. By automating key processes, CRETA helps manage and shorten the software update release cycle. With its automated software release integration, CRETA ensures a smooth and efficient workflow, reducing manual effort and minimizing errors. The integrated API allows seamless connection to existing CI/CD pipelines, enabling full process automation. Therefore, an efficient collaboration between software and calibration teams is provided. A structured review process with a software update management system support ensures compliance and traceability, while built-in automotive cybersecurity features help meet industry regulations. Additionally, CRETA simplifies the management of software variants and responsibilities, ensuring that the right versions are used in the right contexts. By addressing these challenges, CRETA transforms software development in the automotive industry, making it faster, more secure, and highly efficient. Let's take a closer look at how CRETA tackles these challenges and revolutionizes software development in the automotive industry. To show you how these processes can work together, I will give you a brief introduction. AVL CRETA was specifically designed to solve the problems of developing and maintaining hundreds of different datasets with thousands of parameters. In CRETA, the calibration pilot creates a project with a variant structure and initial data consisting of a software version and datasets with the corresponding parameters. The calibration engineers can then download it, calibrate the data, and upload their calibrations. The pilot merges the calibrations to a new merged dataset. The responsible engineer then checks the merged data, downloads the software and dataset, calibrates again, and uploads his new calibration. The pilot then merges the data to a new dataset. This is an iteration of a calibration process until the final start of production version of a dataset is finished and ready for a release. So let's start with a standard workflow in which we first import the data manually. Later, I will show you how the whole process can be automated in a CI/CD pipeline. First, we import a software. Then select your software version. This A2L file can be provided either by an external supplier or by an internal software development team. Rename it as desired and select Start to import your software. In the main tree, you can now see your first imported software version. The revisions folder contains the different variants of a project to which the datasets are assigned during import. In this example, we assume a vehicle that is available as a standard and long-range version, as well as a performance version for different countries. The availability in different countries also varies. This simple setting already results in 8 different variants and therefore 8 different parameterizations that need to be developed and maintained. So the next step is to import the datasets that belong to the respective variants of a software version. Therefore, select in the Workflow tab Import Revision. Select your dataset and rename it as desired. Click Next and select the software version to which the dataset belongs to. In this example, the base software is Software 1. Click again Next and select the variants where the dataset should be imported. For demonstration purposes, I select all variants once. Then you can click Next and Start to import your dataset. In the status overview, you can see the corresponding number of parameters that have just been imported. As we can now see in the Revisions folder, the datasets are now imported in the previous defined variants. In the software name column, you can also see the corresponding base software. Now the work of the calibration engineer begins, who creates his calibrations based on the datasets. As an engineer, you can then select in CRETA Import Calibration to import the calibration file, usually a DCM file or CVX or PACO, which can contain changes to values or metadata such as score or comments. Here you can add your calibration file and assign it to multiple variants at once where you would like to apply the changes. Select Next and Start to import it. The status provides then an overview. The calibration is now imported to the previous defined dataset. As pilot, you can now merge the dataset with the calibration file. Therefore, right-click the dataset and select Merge Revision from CBs. Define the name of the new merged dataset and select Next. Here you can select the calibration which should be merged. In this case, the new one calibration is automatically selected and we can click Start. The status overview displays the successful merge. In the main tree, you can now see the new merged dataset displayed with a yellow icon. To ensure a correct merge, CRETA supports this with a responsibility management that the administrator can assign down to parameter level. The review policy feature also offers further options for preventing merge conflicts. Warnings that CRETA displays automatically after a merge can be defined individually with specific triggers. In the next step, it is possible that a new software version is available. In the past, software versions were updated no more than twice a year. Nowadays, the update frequency is much higher, sometimes daily or even faster. This increased frequency requires a much higher level of automation, not only for testing, but also for the displayed process. Therefore, I want to demonstrate this delivery process with CRETA again, but this time fully automated through a CI/CD pipeline. For this demonstration, we will use GitLab as the version control system for the software code and GitLab pipelines for the automation. Of course, you can use another automation system of your choice to implement the following use cases in your environment. I will now simulate a code change that creates a new software version. To make a code change, select your software, Edit, and Edit single file. Make your desired code change and select Commit Changes. As in any CI/CD environment, this commit triggers an automated pipeline. Switch to your corresponding pipeline then. In this example, the pipeline consists of 4 steps. The first step is the creation of the software. Then, unit tests are executed, typically followed by software-in-the-loop tests. If these steps are successful, the new software version is qualified to be handed over to the calibration department. The final step is then the delivery to CRETA. Once this process is complete, the calibration engineers can work with the new software version. So let's go back to CRETA. After a refresh, the new software with the corresponding datasets is displayed in the main tree. As you can see, the transfer process from software development to calibration is fully automated and does not require software developers or calibration engineers to leave their preferred tools. The higher release frequency not only brings with it new challenges in the handover between departments. The constant updating of the software also places high demands on verification and validation. Does the parameterization still work after the update? Do my changes have an unintended effect on other areas? Ensuring that parameterization works is no longer possible with purely physical tests. These processes must be supported by virtualization, such as software-in-the-loop tests. And that brings me to the next part of the video. Calibration engineers also need automated tests and automated pipelines to cope with higher software release frequencies and the demands of modern development. The problem is that calibration engineers are usually not familiar with CI/CD pipelines and the tools used, such as GitLab. User acceptance and the change process are major challenges. The latest features of AVL CRETA solve these challenges by integrating automated pipelines into the CRETA environment. The information provided by such pipelines can be found directly in CRETA, and necessary interactions such as triggering, manual interventions, and so on can be performed directly from CRETA, the tool that calibration engineers already use and are familiar with. Let's take a look at how this is done in our demonstrator. We now have the new software and the corresponding dataset, which has been automatically integrated. The engineer has also already imported the calibration file with the necessary changes. As a pilot, we now merge the dataset with the new calibrations. To do this, right-click the dataset and select Merge Revision from CBs from the context menu. Rename it as desired and select Next and Start. As soon as this new dataset is created, the CI/CD pipeline is automatically triggered. This is indicated by the icon in the Status column. To get an overview of the currently running pipeline, select Tools, Add-ons, and select the appropriate pipeline. For demonstration purposes, we have 3 stages in this example that provide relevant information for calibration engineers about the software-in-the-loop process. The first stage displays the setup of the environment. The second stage is the execution of the SIL tests. If the SIL tests are successful, it is assumed that the parameterization is qualified to be returned to software development via a commit or a pull request to the software repository. This enables the software developers to improve the software based on a realistic and up-to-date parameterization. In addition, it is possible to release the software and its variant-specific parameterization directly from CRETA. This depends on your internal process. In addition to the current pipeline status, you can also get information about pipeline executions from previous parameterizations and other pipeline executions for the same parameterization. The final stage is the delivery and thus closes the software development cycle. The overall status is also displayed for the appropriate dataset in the status column. In this case, we have a successful completed delivery, which is represented by the green symbol with the tick. In addition, the SIL test report is attached and directly available in CRETA. This provides very easy access and traceability for calibration engineers. This completes the cycle. The new datasets are returned to the software repository, in this case as a new commit. This is created automatically without the calibration engineer needing any additional expertise. Here you can see the new commit containing the updated parameterization. All this was done without the software engineers or calibration engineers having to leave their tools. So the first benefit is that nobody has to leave the familiar tool chain. What is even more important, however, is that the information is displayed directly in the work context. You do not have to look up the required information in different places, and there is no need to change the context. And on the top of that, the changeover is not disruptive. No new tools need to be introduced, no additional licenses need to be purchased, and only a small amount of training is required. In summary, the challenges in automated software development can be solved by separating software development and parameterization. CI/CD pipelines help to support such separate processes in a convenient way. CRETA supports the transfer of software development to calibration and also the automated way back as soon as qualified parameterizations are available. Virtualization, such as SIL tests, can be integrated into the daily work of calibration engineers to create an automated safety network that further increases development speed and quality. In this way, we are rethinking the calibration processes with a focus on speed, security, and scalability. So let's release.